Find the distance and displacement for a body along a circular path of radius 14 meters in each of the following cases. Before we get on to the sum, we need to know certain formulas. And here we know we have a circle like this. The circumference of the circle is given by the formula 2 pi r. If it is half a circumference, so it will be 2 pi r divided by 2, which is pi r. The 2 will cancel out. And if I have a quarter of a circle, what would be a quarter of the circle? From here to here, say, okay? That would be 2 pi r divided by 4. So we need to remember this. A full circle circumference is 2 pi r. Half a circumference, that's from this point here to say this point, between these 2 points, this distance here will be pi r, and then we have the quarter of the circle. Now in this sum, in the first part, they are saying find the distance and displacement when a body completes one revolution. First, let us start to calculate the distance. Now, to calculate distance, the body starts from, say, this point here. We call it A. And it completes one revolution. So it goes right round like this, round the circle. And it comes back to this position. It leaves here, comes back to the same position here. I'll put the final position in another color. It comes back here. B is its final position. So the distance, you definitely agree, is 2 pi r. Is the circumference traveled by it. This 2 pi r. And this would be 2. 22 by 7. In this case, the r is given as 14 meters. So 14 meters. And when you cancel this out, you have here 2. So this answer would be 2 into 22 into 2, and that would be 88 meter. But now when I want to know displacement, to find displacement, I must know which is the initial position and which is the final position. So in this case, we saw the initial position was A, and the final position was B. So, and A and B coincided. What is the distance between A and B? It's very obvious here in this area. We see AB is 0. A and B coincide. The initial and final position is same. So in this case, the displacement is equal to 0. Zero meter. Why did the displacement become 0? Because the object returned back to its initial position. The initial and final position was one and the same. Now for the second, when a body completes half a revolution, we need to find distance and displacement. So let's start off again with the body at this point A. And now it's going to cover half a revolution. So it reaches here, it goes right round. Remember, it's just half a revolution. And it will come at this point here. Here at this point. And this is B. So the distance covered will be circumference divided by 2. Have you seen? It's half a circumference, this, not the full. So it will be 2 pi r divided by 2. Divided by 2. That is 2 pi r divided by 2. You strike this out and you get here pi r. So it will be 22 by 7. Your r is 14. So you reduce this into 2. So here you will get 44 meter will be the distance. Now what is the displacement? To know the displacement, first we have to find out which is the initial position. So now we are finding out displacement. So our initial position we know is A, and the final position, now the object has come to B. Here the object is B, the final position. So here is initial, this is initial position, that is A, and this is final position, that is B, and the distance between them, that is AB, will be a displacement. AB is the displacement. We just write here our final position here is B. Now how much is AB? If you notice here, the AB is the diameter, which we know if radius is 14, your diameter will be 28 meter. So our displacement is AB, which is diameter, and that is 2 into 14, and that is 28 meter will be the displacement. So your yellow line here, this yellow line is distance, while the blue one here is displacement, the shortest distance between the initial and final position. Now we are doing the C, when a body completes 2.5 revolutions. So let's go for the first revolution first. So it covers it completes of one full circle, which is 2 pi r. It's 2 pi r, then 2.5, then it covers a second one here. That is another 2 pi r and a half, and now the half will be from here, the third is just the half from here to here, which is now 2 pi r divided by 2, that is 2.5 revolutions. Remember, it was 2.5 revolutions. Okay, so here was the initial position we saw was A, and the final position, now it is stopped at B. This is its final position. So this was initial, and this is the final. So let us find distance and displacement. With the distance we said 2 pi r plus 2 pi r by 2. So it is 2 pi r plus 2 pi r, and this cancels pi r. That means 2 plus 2 plus 1, 5 pi r. 5, 22 by 7, your r is 14. So we cancel this, we get 2. So answer will be 220 meter. This will be the distance, the actual path followed. It's got 3 circles. It takes the yellow circle, it takes the yellow, then it goes again the green and half red. Now for the displacement, we must know what is the initial and final position. So we saw the initial position was A and the final position is B. And that is the case, your AB will be your displacement. This blue line is the displacement. And we see that AB is the diameter. So we have displacement is AB, which is a diameter. And we know the diameter in this case is 2 into 14, which is 28 meter. So displacement equal to 28 meter. This is displacement. Distance equal to 220 meter. 220 meter. Now for the fourth, when a body completes a quarter revolution. So it's at point A. Now it's covering a quarter revolution. So it will go up here till here. This will be a quarter. This will be your point B. See, hope you've understood this. This is a quarter. This full thing till here was half. Half of half is quarter. So now let us see what is the distance. Now we'll definitely agree that distance will be quarter circumference. That will be 2 pi r, which is a full circumference, divided by 2. So divide by 4, not 2. So the distance will be circumference divide by 4. Why divide by 4? Because it is quarter revolution. That is 2 pi r divided by 4. That pi r divided by 2, 22 by 7. Your r is 14 and into over 2. This 2 I write here. So the answer here is 22 meter. This is the distance. 22 meter. Now for the displacement, we need to note which is the initial position. This was the initial position and this was the final position. And the distance between them is this. This is my displacement. So my displacement is AB. Now the question is, how do I find AB? To find AB, I do something different now. Suppose this is the center of my circle. Here, I'm just going to join up OB and OA. And you'll definitely know that this is 14 because radius is 14 and this is 14. Could you guess now how to find AB? We are going to use Pythagoras theorem in this triangle. This triangle we are going to do the Pythagoras and then we will find our AB. So let's get on to do the Pythagoras theorem. In triangle OAB, we know our hypotenuse is the blue one and that is AB square. AB square equal to OA square plus OB square, and your AB square equal to 14 square plus 14 square. Now see, I'm not finding 14 square. Okay, so I'm doing AB square. There is 14 square and there is 14 square. How many 14 squares do you have? You have 2 times 14 square. So your AB will be the under root of 2 times 14 square. And your AB will be equal to 14 under root 2, which is your displacement. 14 under root 2 meter will be your displacement. So this is 14 under root 2.